Center of mass. We will discuss it by taking the example of a system. So you should know what is a system. System is defined as when two or more than two bodies join and work together, then they form a system. Now center of mass, which is defined as center of mass of a system is such a point where an applied force causes the system to move without rotation. It means when the force is applied on the system at a point, it moves, no rotation is produced in that case. The entire mass of the system is confined at this point. It means whole mass of the system is present in this very small area. Now for explanation, consider a system of two particles A and B connected by a light rigid rod as shown in the figure. Now for the location of exact center of mass of the system, we will discuss it by the help of the following cases. Case number 1. Let O be a point between A and B such that the force F is applied at that point O as shown in the figure. The system moves in the direction of the force without rotation. So point O is the center of mass of the system. Now case number 2. Let the force be applied near the lighter particle as shown in the figure. The system moves as well as rotates. It means that this is not the point of center of mass of the system. Number 3rd case, let the force be applied near the heavier particle as shown in the figure. In this case, also the system moves as well as rotates. It means this point is not the center of mass of the system. Now in the end you will write the conclusion. After discussing all these cases, we come to know that point O selected in case 1 is the exact center of mass of this system, because when the force is applied at this point, the system moves without rotation. Next topic is center of gravity, a point where the whole weight of the body appears to act vertically downward is called center of gravity of that body. Now explanation. A body is made up of large number of particles as shown in the figure. Earth attracts each of these particles vertically downward towards its center. This force of the earth acting on a particle is equal to its weight. These forces acting on all the particles of the body are almost parallel as shown in the above figure. The resultant of all these parallel forces is a single force equal to the weight of the body. A point where this resultant force acts vertically downwards to the center of the earth is called center of gravity of the body. It is denoted by capital G. Now importance of center of gravity. Number 1, the location of center of gravity of a body helps in solving the problems dealing with equilibrium. Number 2, it is also useful for the stability of a body while this body is moving or at rest. Center of gravity of some symmetrical objects. The objects which have regular shapes are known as symmetrical objects. If an object is rectangular in shape, its center of gravity can be found by joining its diagonal. This is one diagonal which is obtained by joining the opposite corners. Another diagonal. These two diagonals are intersecting each other at a point. This point is its center of gravity. If you want to balance this rectangular shape object on the tip of a pencil, you can balance it at its center of gravity. If the object is square in shape, again its center of gravity is found by joining its diagonals. So intersection of these diagonal is its center of gravity, denoted by G. If the object is circular in shape, its center of gravity will be the center of the circle. This is its center of gravity. Intersection of its medians. So G is the center of gravity of this circular shape object. If the object is triangular in shape, its center of gravity is found by drawing its medians. Median is a line which divides the side of a triangle into two equal halves. So this is one median. The line which is dividing this side of the triangle into two equal parts is the another median. Third median is this, which is dividing this side into equal parts. So this point where these medians intersect is known as its center of gravity, noted by capital G. If the object is circular ring, again its center of gravity will be in its center. So center of gravity will lie in its center. This point is the center of gravity of the ring. You can balance this ring at this point. Actually it will balance at this point. If the object is cylindrical in shape, then its center of gravity is the intersection of its axis. The object is cylindrical in shape. This is vertical axis which divide the cylinder into two equal halves. This is horizontal axis which divide again the cylinder into two parts. So this point, intersection point, will be its center of gravity. So in this way we can find the center of gravity of regular shape or symmetrical shape object. Center of gravity of an irregular shaped thin lamina. A simple method to find the center of gravity of an irregular shaped object is by using a plumb line. You should know what is a plumb line. A plumb line consists of a small metal bob which may be of lead or brass supported by a string. When the bob is suspended freely by a string, it comes to rest along the vertical direction due to its weight acting vertically downward as shown in the figure. Now by the experiment you will come to know how you can find the center of gravity of irregular shaped thin lamina. Here we are taking irregular shaped piece of cardboard which is a thin lamina. Now take an irregular piece of cardboard, make holes A, B and C as shown in the figure near its edge. Fix a nail on a wall. Support the cardboard on the nail through one of the hole. Let it be A, so that the cardboard can swing freely about A. The cardboard will come to rest with its center of gravity just vertically below the nail. Now draw a vertical line from point A or hole A using a plumb line hung from the nail. Mark the line on the cardboard behind the plumb line. Now repeat it by supporting the cardboard from hole B. Again draw a line on the cardboard behind the plumb line. This line from hole B will intersect the first line already drawn by hole A at point G. This point may be its center of gravity. You have to confirm it by drawing another line from the hole C. Note that this line also passes through the point G. So it will be found that all the vertical lines from the holes A, B and C have a common point G. This point G is the center of gravity of the cardboard.